Hi guys, welcome to the Tech Granth. Today we are going to solve the Leetcode problem, sliding window maximum. Do like and share the video, subscribe to the channel the Tech Granth to get the future updates. So the problem here is we are given an array of number and we are given a constant k. This k denotes the window, like what will be the size of the window where we have to get the maximum value. The explanation given here is pretty good, so we'll just go through it once. So it says that this window is of size k, so size 3. So here we take the 3 element from the num array and we get the maximum value of this window. Similarly, and the window slides by one position every time. So here we are getting the max of this 3 element, then max of these 3, and so on. So we need to give the output in this format of int, means in an int array, each element representing the window and the maximum value for that window. Okay, so when I first looked at this problem, the first solution that came to my mind was why not use a priority queue. Basically, we use a priority queue, and for each of the window I will insert all these elements in the priority queue, and when I slide my window, then that time I will remove the first element from this priority queue and add the next element. So basically when I reach from this point to this point, I'll remove this element and add this element, and so on. I'll remove this and add this, and the priority queue we can give a formula to keep the biggest element on top of the queue. So that was a pretty okay kind of approach. The only problem was the time complexity it was taking was almost n log n, because the challenge was when you remove element from a priority queue, it takes almost log n time, maybe little more than that. So that's why for a bigger set of problem, that solution was not that good. It might have caused time limit exceeded error. So the second thing that second approach that I took, I'm going to explain that here, and it's pretty good approach, and it happens in linear time basically. So what we can do here is we need to partition all these number as per the value given here, value of k. So we'll do something like this 1 3 minus 1, then I partition it. I'll do minus 3 5 and 3, and again I partition it, and we have 6 7. So this approach came to my mind when, because it was relatable to one of the problem that I solved earlier, and I think I created a video for that also, which is the trapping rainwater problem. So when we solve that, what we do is we go from left to right, and we calculate the local maxima. Same thing we do from right to left, and we calculate the local maxima. Now only difference from there to here is we have chunks. Here we have to partition it. We need to get the local maxima for the chunk of this size k, whatever is given here. So we need to partition it, and all the maxima will be based out of the chunk. Like for this the maxima will be 3, for this it will be 5, and so on. So if I have to move from left, so my maxima will look something like, at this position it will be 1, at this position it will be 3, at this position it will again be 3. Now I reached my partition here, so I have to reset my maxima. So here it will be 3 5 5, then again reset 6 and 7. And when I come from right hand side, so when I come from right hand side, what I need to do is I'll work with the right hand side. So it will be 7 here, then again 7 here, then I reset, and it will be 5 here, then again 5 here, then oops, sorry, this will be 3 basically, this will be 5, this will again be 5, then again I reset, and this will be -1, and then this will be 3, and this will be 3. Okay, let me just adjust it a little. Okay, so this is decent enough. So this is how the left and right will look. So when I come from right hand side, I reset here, so this is -1, 3, and this will be 3. Now the result, how the result will look like for me. So how I will calculate my result, since I have a sliding window here, so first window is this one, so the maximum will be, since this position is when I am coming from the right hand side, so this will always be the current position for maximum, and for the left hand side, for this particular partition, the maximum value will always be at the end of my partition. So if I'm considering this partition, this particular window, so the maximum value I will get it will be at the end of my window. So I need to take the max of these two basically. So here the max of 3 and 3 is 3, so I will take 3. Next, my window has I have slide the window from here to here. So at this particular, the end of the window, the max value was -3, and here it's 3, so it will be max of 3 and -3. So next result will again be 3 for me. Again I slit the window from here -1 to 5, so the maximum will be -1 and 5. I'll compare these two, so result will be 5. When I slide my window from -3 to 3, so I need to take the max of this and this, so it will be 5 and 5, so it will again be 5. Now I have to slide my window from here to here, so it will be max of 6 and 5, so it will be 6. And finally the last one is from here to here, so it will be max of 7 and 3, so it will be 7. So my final result will be array of this number, it will be 3 3 5 5 6 7, which is same as what we have here. Okay, if you have some doubt, just go back in the video, or you put some comment where you are able to, where I'm not able to explain this, so I can explain it again to you guys. Put the comment for that. And if you have understood this approach, then maybe you can pause the video and code yourself. Otherwise you can just proceed with the video. So let us try to code this. We'll say int of left is equals to new int, this will be of size nums dot length. We'll have int of right, this will be new int of nums dot length, and we'll have a result. So the result array, this is equals to new of, and this will be nums dot length minus k, whatever we are getting, plus 1. So because the result array will be smaller than the original array, and it will be smaller by whatever k value has been given, and plus 1 size. So if this array is of size 8, so it will be 8 minus 3 5 plus 1 6, so the output will be of length 6. Okay, now we will populate our left side and right side. So I will go from int I equal to 0, I less than nums dot length I plus plus, and my left of I, and what I need to do, actually I'll start from 1. I will simply say left of 0 is equals to nums of 0, and the right of nums dot length minus 1 is equals to nums dot length minus 1. I'll initialize these two position and I'll start from 1. So my left of I is equals to, so since I need to partition this, so every time I mod k is equal to 0, so it means we are at the first element of this particular partition. So when this is equals to 0, so I will take my nums of I, which is this element or this element. Otherwise I will take math.max of whatever left element was there. So in this case either this left element of left previous element or nums of I. So for this particular case, since this is ith position is 0, so 0 mod 3 is equals to 0, so the left of this position will be num of I, which is num of 0, so it will be 1. Now this is position 1, so 1 mod 3, it is not equal to 0, so it will be max of left of I minus 1, which is this, or the number itself, so which is 3. Again when I come here, so it will be max of the left the previous left element or the current element itself, so it will be 3. So this is how we populate the left array. Now same thing for right array. So right array we will populate from the very end, so it will be nums dot length minus 1. We start from here, and for populating populating the right side of the array, basically, so we will populate the ith position. Basically it will be minus I minus 1, because we start from the I will increase from this side and we have to decrease the value from here. So the first element that we will populate is whatever length minus 1 is, this, and minus 1. So because we have initialized this element already as nums of length minus 1, so we need to start from here. So it will be nums of it should look like this, actually, minus 1 minus I. This makes more sense. So it will be this element, then this element, then this element. So again the same formula will apply here. If this position, basically this I minus 1 position mod of k is equal to 0, if this condition is true, in that particular case we will pick the element from nums. So it will be nums of nums dot length minus 1 minus I. Otherwise we will pick the max value. It will be math of max, and it will be basically the right element. So it will be nums dot length minus 1 minus I and plus 1, which will be like, which effectively will be nums dot length plus 1. But anyway, for explanation this seems better, and nums dot length minus 1 minus I. So it will be max of these two elements. So that is how we populated our left and right. And once this is done, then we need to populate our result. So for result, int will be from 0 to I less than nums dot length minus k plus 1 I plus plus, and we will have our result of I. This is equal to math dot max. Now from right side we will take the same element like I explained here. So it will be right of I, and for left side it will be the edge element of, means the rightmost element of the sliding window that we have. So it will be I plus k minus 1, which will give me this element. So if I value is 1 and the sliding windows of 3, so the value of this will be 3 minus sorry yes, so the value of this will be 3, because 1 plus 3 minus 1 will be I of 3. So I'll get that element. So that is fine, and in the end we'll simply return result. Let's try to submit this. Seems fine. Yep, it works fine. It ran in like 4 milliseconds, which is very nice time. So hope you understood how we solved this problem. If there is any confusion, do mention that in the comment section. See you in the next video. Bye.